Okay, I think we actually did not complete 35 yet. I think we started it and I didn't get all the way through it. Or I finished it as the bell rang. Did you guys want me to go back through 35 again? Or are you good with that one? Yeah, good. All right, let's go on to 36 then. So on 36, lines AC and FG are parallel. Which statement should be used to prove that triangles ABC and DBE are similar? Now, if we're talking about parallel lines here, there's a couple different properties that we could use. We could use things like alternate interior angles or same side interior or corresponding. Now, looking at the diagram of what's there, since we're trying to prove that the triangles are similar, we'd have to be dealing with angles that are inside these triangles. Well, alternate interior angles, alternate exterior angles, those things aren't going to help us since we're dealing with a triangle. What's going to help us is the fact that these corresponding angles are congruent, and these two corresponding angles over here are congruent, because then we could prove that these two triangles are similar by AA. Well, do any of these options give us either of those two sets of angles? So first, looking at option A, they say alternate interior angles. Again, that's not going to help us. The last option says alternate exterior. Not going to help us. So the only ones that use corresponding are options B and C. So it has to be one of those two. Now, which one correctly matches the right angles? Well, B says BAC. All right, so we got this angle down in the corner with 1. And then we have BEF, which is the angle way out here, which makes no sense. All right, that's not part of the triangle even. So C can't be it because of which angle they use. Looking at D, those are these two angles that are marked with 2 congruency marks. So D is our correct answer. Oh, sorry, not D. My bad. I just did the wrong. I skipped down. My bad. Let me try that again. I've done this problem 3 times already. Let me do it one more time. Correct. So, sorry. I read off this one, BEF, and I crossed off the wrong piece. I skipped down a line. So BEF was the one that I scribbled out here. Again, that one was the one that made no sense. And then the other two that were on option C are the two that are in the correct position with the 2 lines. So C is the correct answer. All right, moving on. 37, we have a diagram. I could not imagine that they would ever ask you a question like this on the FSA. And I don't know who chose to do this one because we never even used these symbols. So that's a symbol that we use in logic. And we don't really do that in geometry, at least not currently under our current standards. So A is the one that's not correct. And you could probably guess at that based on the symbol that they used because you guys haven't seen it before. But again, not really necessary. Same thing with 38. They're doing the same thing on 38. They're actually doing the proof that they're talking about in 37. But the proofs on the FSA are not completely blank. They are not usually that challenging of a question. They're usually ones dealing with triangles being congruent, proving sides are the same. A lot of the early proofs that we did back when we were talking about triangles being congruent or corresponding parts in quadrilaterals, we're not going to be proving Pythagorean theorem. So 38 is a little bit extra. Like I said, I'm not even going to bother with that one because it's a little too much. On 39, again, diagrams, not the best diagrams here, but the idea here is they are making a right triangle with the shadow and the tree. And they, since they are the shadows of these trees, they should be the same ratio. As far as the answer choices go, again, there's like a couple mistakes here in a row. Forget about those answer choices. Those don't make sense. The shadow has to be longer than the height of the tree. If you look at the first diagram, the shadow was almost double the height of that tree. So the shadow in the one we're looking for should be almost double the height of that tree, which is none of those answers. Now, how would you do a problem like this? Proportions. So set up proportions so that you had two equivalent ratios. We can set up a proportion 4 different ways for any proportion. So on this one, if you want to use the numbers from the same figure, that's fine. I could say 17.5 is the height of my tree, 31.5 is the length of my shadow. And then on the other one for the smaller tree, we have 7.5 for the height of the smaller tree and X for the length of the smaller shadow. When you set up a proportion, you have to make sure there's something that is related both horizontally and vertically. So for example, here I set the first one. So vertically, everything in that first ratio is from the first diagram. Everything in the second one is from the second diagram. Horizontally, going across the top is the height of the tree in both situations. The bottom is the length of the shadow in both situations. Now, if you set up a different proportion, how do you know if it's correct? Well, diagonally, the same numbers should be across from each other. So if you have a proportion set up and you have the same numbers diagonally, you're fine, because the next step is to cross multiply. So once we cross multiply, we should have the same values no matter what. So we should end up with 17.5 times X equals 7.5 times 31.5. So now, once you have that equation from cross multiplying, simplify and then solve for X. So we have the 7.5 times the 31.5 gives us 236.25. Divide off the 17.5 and you get 13.5, which I said earlier, just looking at the first diagram, our shadow is almost double. Here, our shadow is almost double the height of the tree. So again, that looks like an answer that is correct. If it was multiple choice, you might even be able to get away without doing some of the work, because looking at how they compare in the two diagrams, there might only be one answer that's close. Right. Again, there are quite a few questions that are multiple choice. Not all of them. Some are free response, some are select all apply. Again, there's different styles of questions, but there are still quite a few multiple choice. All right, number 40. Again, label the figure as you go. You'll have to draw diagrams since it's a computer-based test, but on here we have a lot of information given to us, including that each of the flags around the Washington Monument are 100 feet from the base of the monument. And we also know that the flagpole to the height, to the top of it, is 564 feet. And they want to know what the angle of elevation is by the flagpole. So angle of elevation is coming from the ground going up. So we're going to call that X. Now, this is our first problem that we have to use trig for. So when we are doing trig, there are 3 main trig ratios: sine, cosine, and tangent. On the reference sheet that I gave you on, what was that, Monday? Tuesday? I don't remember what day I gave it to you. I think Monday. The reference sheet has the 3 trig ratios on it. So if you forgot them, fine, look at the reference sheet. Should you already know them by heart? Yes. Will you need to know them next year? Yes. So those ratios, again, are sine, cosine, and tangent. There's a saying I gave you at the beginning of the year to help you memorize it. Or it's not beginning of the semester that you might memorize it. It was some old hippie caught another hippie tripping on acid. And the reason why we did that was because we had sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. In order to know which one to use, you had to say what 2 pieces you had for this diagram. So the 100, it's next to the X value as far as the legs go. So this is our adjacent leg. The 564, that's on the longest side. It's across from the right angle. This is our hypotenuse. So we're using adjacent and hypotenuse, which is cosine. So cosine of the angle measure, which is what we're looking for, equals adjacent, 100, over hypotenuse, 564. We got to get X by itself. When we're solving for an angle measure, that's where we use the inverse function. So we're doing the inverse cosine to find our answer. Let's take the inverse cosine of both sides. we're doing the inverse cosine of 100 over 564. And that's what you have to type into the calculator. If you want to do the fraction first and get a decimal and then do inverse cosine, that's fine. I think you get like, let's see. Let me just type it in real fast and see what it was. I don't remember. 0.1773. All right, so we're doing the inverse cosine of 0.1773. So what's our final answer? It is, what do they want us to round to, nearest degree? So we get 79.7, which rounds up to 80 degrees. All right, going to 41. In a scale model of the Millennium Dome in Greenwich, England, was constructed on a scale of 100 meters to 1 foot. The cable supports are 50 meters high and form a triangle with the cables. How high are the cable supports on the scale model? So, all right, on this one, they gave us a couple different dimensions. They said that was a scale of 100 meters to 1 foot. 100 meters to 1 foot. That's our ratio. Now, do I have to do conversions on this one? Yes, they give you a table and chart of all these conversions, but you don't have to use it on this. All right. We are setting up a second ratio, and we're going to use those same units. So since we're using the same units, we don't have to convert anything. We have 100 meters on top for the first fraction. On the second fraction, we have 50 meters. We need to know how many feet, because all of our answers are in feet. So x feet. We're cross multiplying and solving. 100 times x equals 1 times 50, which is 50. Divide by 100. And 50 divided by 100 is 1/2 or 0.5. And that's our answer, 1/2 of a foot. On 42, they give you a lot of information here. We have Rachel, who has the mirror on the ground. We have those two angles both labeled as x because they have to be congruent. These two figures would have to be similar. So we already know that those two angles are the same. They tell us the height of Rachel was 5 feet 6 inches. Our final answer has to be in feet. So just write your answer in, or your numbers in feet here. 5 feet 6 inches is the same as 5.5 feet. Because there's 6 inches in a, sorry, there's 12 inches in a foot. So 6 divided by 12 is 0.5. The lamp post, that's the height we're trying to find. They also told us that the mirror is 20 feet from the lamp post, and she stepped back 4 feet. So those are the pieces that we have to work with. We're going to set up a ratio. Again, when you do this, you have two ratios that equal, that's a proportion. There's 4 different ways you could set it up. Does somebody want to give it a shot? What's one proportion that could work here? Anybody? What's one proportion that could work? All right, we can start there, 5.5 over 4. Now we have to make sure, so these both came from the side that Rachel was on, and we had her height over the distance from the mirror. So we have to make sure we follow that same pattern for the lamppost now on this side. The height of the lamppost over the distance of the mirror. So what are those two pieces? X over 20. All right, so something like that would work. Cross multiply and solve. No matter what your proportion looks like at this step, if you set a correct proportion, we should now be doing the same thing. So we get 4x is equal to 110. This does not come out to a whole number. This is x equals 27.5. Yeah. So, and that is our final answer, 27.5 feet. All right, 43. Back to some trig. All right, on here, both of these problems actually are requiring some trig. So we have sine, again, some old hippie, cosine, another hippie, tangent, tripping on acid. For the first diagram, where they have the question mark, that is what we're trying to find. So I'm going to call that X for right now. We have 41 is our angle measure that we're using. Labeling this figure based on the angle we're using. This is our hypotenuse. This would be our adjacent. So for this problem, we're using cosine. So cosine of 41 degrees equals adjacent, which is X, over hypotenuse, which is 30. Now, keep in mind, anytime you do a problem and you're plugging it into your calculator, I forgot to mention this on the last problem, you need to make sure that you have it in what mode? Degree mode, because all of our angles that we're using are in degrees. So you need to make sure your calculator is in degree mode. If you do everything correct, except your calculator is in the wrong mode, your answer will be wrong. All right. So now on this one, we have our equation set up. We need to solve for X. And first step is pretty much always the same. We got to get rid of the denominator by multiplying it over to the other side. So we have 30 times cosine of 41 equals X. And you can plug that whole thing into your calculator. Make sure if you're using a calculator that's just one line, you make sure you hit equals at the end. Don't just do cosine of 41. So 30 times cosine of 41. That's going to be 22.6. Now, that answer is not there, but it did say closest. So 22.5 feet, 22.5. That would be our answer. On 44, what is the sine ratio of angle P? So we have angle P. Sine is opposite over hypotenuse. 15 is opposite. 17 is hypotenuse. So we're doing 15 over 17, which is option C. On 45, this one was a little bit of work. This was like 3 questions in one. So they gave us a couple of the dimensions, and they gave us 2 separate triangles. So starting off, we have to use the one that they gave us over here of 41 degrees. And if that's 41 degrees, the 34 feet that they gave us is our adjacent side. And they want us to find the height of this, which is going to be our opposite side. So I'm going to call this piece X for right now when I plug it in. How tall is the pole? Well, opposite and adjacent. What uses opposite and adjacent? Well, sine was opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Some old hippie caught another hippie tripping on acid. Again, they do give these to you on the reference sheet. If you know them, it will save time still. We're using tangent. So tangent of the angle measure, 41, equals opposite, which is what I'm trying to find, X, over adjacent, which is 34. To get X by itself, we're multiplying 34 out of the denominator to the other side. So 34 times tangent of 41 is going to give us our answer. So plug it in. Tangent, 34 times tangent. Calculator's not cooperating. 34 times tangent of 41 is 29 point, I'm going to round it off to 29.6. And this will be in feet. Now, there are a couple extra decimals there. So you might want to write it down so that you have extra decimals, or keep using the values from your calculator. But those would be the next few decimals if you want your answers to be more accurate. The next one, how far from the base of the pole does wire 2 attach? So now we are no longer using that original triangle. We're now using the other triangle that they gave us. So now, focusing on this triangle over here, 38 is at the top. This piece that we had just solved for where X was, this is now our adjacent, and this is our opposite, and wire 2 is our hypotenuse. So on the next question, how far from the base of the pole does wire 2 attach to the ground? Well, we have the adjacent, and we need to find the opposite. So actually, we're doing almost the exact same thing. We're doing tangent of 30, what was that, 38? Is equal to opposite. That's what we're trying to find. I'm going to call it X again, over adjacent, which we just found was 29.5. So how do we get our answer? Multiply the 29.5 over to the other side times tangent of 38. Plug that whole thing into the calculator. Times tangent of 38. We get 23 feet. Again, just rounding off. If you round it off to one decimal, it would have been 23.1. If you want to know the rest of the decimals, it's 23.09148. We'll stop there. How long is wire 1? Now, you have two sides. You could do Pythagorean theorem, or you could choose just to keep doing the trig. I'm just going to do trig one more time. Doesn't matter which piece I use. I'm going to do opposite over hypotenuse, since we haven't done that one yet. That's sine. So sine of 38 equals opposite, which we just found was 23.09 over our hypotenuse. Well, in this one, we still got to get the bottom over to the other side, but it's a h on the bottom this time. So we're trying to solve for it. So it's going to take a little bit extra as far as our steps go. We have our hypotenuse times sine of 38 equals 23.09. You have to divide off the sine of 38. And when you do that, you get 37.5. All right. 46, we have ourselves a triangle, and it is a special right triangle. It says do not use a calculator. You shouldn't need a calculator. On here, if I did sine of 30, well, here's 30 up here. Opposite over hypotenuse, that's going to be 1 over 2. Cosine of 30, that's adjacent over hypotenuse. So that's radical 3 over 2. Again, this would be opposite, adjacent, and hypotenuse. Now, the other two, sine of 60 and cosine of 60, do I really have to do those two? Don't have to. There's a property that allows us to know what those are right away, since we've already done the other angle. Now, if you want to do them, then using this angle, this is now adjacent, this is now opposite, this is still hypotenuse. So sine of 60 is now square root of 3 over 2, and cosine of 60 is 1 over 2. Again, the property here that we're looking at is the sine of one acute angle of a triangle is equal to the cosine of its complement. So again, the sine of an angle is equal to the cosine of its complement. So the relationship that they're going for each time here is the fact that these two values are equal each time. Sine of 30 is equal to the sine of cosine. You could say equal, or you could say the same. But either way you look at it, they are the same values. The last one you have to explain. Why does that happen? Well, when we switch, when in a right triangle, the two acute angles are complements. And when we go from one angle to the other, we have to relabel our figure so that the opposite side becomes our adjacent side and the adjacent side becomes the opposite side. So all of our values switched. If you want to write something like that, that'd be good. All right, on 47. All right, they really went too far here. So I have no doubt that they could probably ask you something like A, B, or C. Maybe even D. Getting down to E and F, it's just a little too much. So on here, for each one of these, you should be saying what the missing value is. Well, sine of blank equals cosine of 55. Sine of one angle is equal to the cosine of its complement. So all we have to do is subtract 90 minus 55, which gives us 35. So the x on this one is 35 degrees. On the next one, same idea. I'm doing a subtracting. We get 68. So our answer here is 68 degrees. Then on C, all right, we have 45-degree angle. Well, this would also then be 45 degrees. On D, again, getting to be a little bit much. The trick on this one, it's the same thing. We're still subtracting from 90. So the 3x minus 1 is not equal to 17. It's equal to 90 subtract 17. So that'd be 73. Add 1, we have 74. Divide by 3, this doesn't go in evenly. We could say either 74 thirds, oops, 74 thirds. Or if you change it to a decimal, .6. Actually, that would round up. That would round up to 24.7. Again, getting to be a little bit much. You don't really have to worry about E and F. That's going way too far. 48. We have Amari observing a woodpecker near the top of the tree. As shown in the diagram below, what is the measure of angle X, the angle of elevation based on the nearest degree? So again, this angle here, we have a side that's next to it. So that's our adjacent piece. This is our opposite. So using sine, cosine, tangent, some old hippie caught another hippie tripping on acid. The one that uses opposite and adjacent is tangent. So tangent of X equals 20 over 36. To get rid of tangent here, we're solving for an angle measure. You have to do the inverse tangent. Again, plugging that into a calculator. That is 29 degrees. All right. Whoops. Why did I just do that? Sorry, let me find where we just were. My computer did something crazy on my side. All right. On the next one, now we're dealing with circles. In which statement explains why all circles are similar? Anybody want to take a guess at that one? Why are all circles similar? It has something to do with pi. Anybody remember what pi is? 3.14. All right. Why is it 3.14? What is pi? It's not C. No. Again, the tricky thing on this one is A, it says there are 360 degrees in every circle. That's a true statement, right? B, the ratio of the circumference to the circle is the ratio of the circumference of every circle to its diameter is the same for every circle. That's true. C, the diameter of every circle is proportional to the radius. That's true. D, the inscribed angle in every circle is proportional to the central angle. That would also be true. So every single one of those is a true statement. Again, which one is a statement that explains why all circles are similar? What you got? Which one? It is not D. Oh, you said B? Sorry. I thought so it is B. It is B. B, that's basically the definition of pi. All right. Remember our circumference formula is diameter times pi. If we're to solve for pi, that's circumference divided by diameter is pi. That's what pi is. Pi is the circumference divided by the diameter. That's why it's always 3.14. It is always the same, and that is why our circles are always going to be similar. because they all share the same ratio of circumference to diameter. All right, moving on, 50. As shown in the diagram below, circle A has a radius of 3, circle B has a radius of 5. Use transformations to explain why circle A and B are similar. What they're looking for here is just an explanation in words of how you could line these two circles up. So you could say something like, we could do a translation of A onto point B. All right, so you're shifting the whole circle onto the other circle. And then do a dilation of 5/3 so that you have it the same size as the other circle so that the two figures are mapped onto each other. Again, I think that's a little bit extra. You're not going to have it. Could they ask you to write something? Yes. Is what they normally ask you to write something long? Not really, because again, it is a computer-based test still, so that's a little bit extra as well. All right, on 51, which statement is true for any two circles? So on here, they keep comparing the different parts of circles using their ratios. What you need to remember is we had 3 ratios when it came to comparing figures. We had a scale factor for single dimensional measurements. We have an area ratio for any type of area, and we had a volume ratio. We just talked about this in the last chapter, right? Scale factor is only for single dimensional measurements, so those should all be the same. Area, any type of area is going to share the same ratio, but you can't mix the two. So going through these, most of these are combining the idea of an area ratio with the ratio of some single dimensional measurement. A says that ratio of the areas is the same as the ratio of the radii. Radii is single dimensional measurement. That can't work. The ratio of the circumference of a circle is the same as the ratio of the radii. Both circumference and radii are single dimensional measurements. B is our correct answer. Just so we see the other two, the ratio of the area of the circle is the same as the ratio of the diameters. Again, comparing area to a single dimensional measurement, not the same. And then D, the ratio of the areas of a circle is the same as the ratio of the circumference. Circumference is a single dimensional measurement. So again, that is also wrong. So B is the only correct answer. 52. Now, I wouldn't be surprised if they did ask something like this. This does look like a type of FSA question I've seen before. So it's kind of similar to 50, but it's asked in a different way. They gave us where a circle was. They asked us to explain or say which one of these explanations could show us how they were similar. So on here, if I had a circle somewhere over here in the first quadrant with a center point at, what was it, AB. So that means that the X value is A, the Y value is B. The other circle that we're going to is over here, centered at the origin. So we need to get this circle onto this other circle. How do we do that? Well, we'd have to subtract to go backwards and subtract to go down. So we're going to subtract the A value from the X's. So we'd have to have an X minus that A value to go backwards and Y minus the B value to go down. And that'd be our first thing. We'd have to translate by that. Well, options A and B say that we're adding, so those aren't it. Then the second part on C and D talk about dilating by a scale factor, and they have 2 different scale factors. One's T over S, the other is S over T. Well, when we do a scale factor, what should go first? The new or the old? New goes on top, old goes on bottom. It's image over pre-image. So the original image had a radius of S. So S should be on the bottom. The new image has a radius of T. So T should be on the top. So it should be T over S, which would be C. All right. We are probably about out of time, right? All right, we'll stop here. That's the same place I stopped last period.